Okay, so in these next couple of videos, I'm going to start going over the topics in chapter 7, which mainly revolves around the idea of a sampling distribution. Now, before we can get into what a sampling distribution is, we need to first learn some basic, terms and definitions so we can talk about it properly. Okay, so let's first just go over like what the whole purpose of statistics even is, other than, it being fun. Like think like what's the whole point of doing statistics? Now you should be like, well, to answer questions that we have about something. Um, let's say you want to figure out what proportion of people um, like dogs over cats, or you want to figure out what proportion of high school kids, since a lot of you are probably in high school, what proportion of high school kids, smoke weed. Maybe you want to figure out what is the average amount of time that a teenager spends on social media per week. So these are questions that we need to use statistics in order to find an answer to. Now, all of these questions, let's just start off with the let's go let's use let's have our question be that we want to figure out is the what's the mean amount of time that a teenager spends per week on social media. Now, there is a true mean, there is a true answer, right? And there's only one answer. Let's say the answer for the true mean amount of time that a teenager spends on social media per week is maybe like, let's say 20 hours or something like that. Let's say the true value is 20 hours. We call that a parameter. So the parameter is the true value of the population that we want to figure out. If we were trying to let's say figure out what proportion of teenagers smoke weed, the parameter would be the true proportion of teenagers that smoke weed. And again, keep in mind there's only one true value. There is a true value. We don't know what the true value is, but there is a true value. Now, what we then do is we gather data. We gather samples, and from a sample, let's say we have 50 students. From a sample, we do an anonymous survey asking each student if they smoke weed or not. And from the sample, we get that 35% of the students say yes, they smoke weed. So that's a statistic. That's a value that we get from a sample, and it's a statistic because we can have different statistics. For example, like let's say we ask another 100 students, how many of you smoke weed, and we get 37% this time. So in a different sample of 100, we got a different statistic. This time it was 0.37, whereas the first time it was 0.35. And maybe we take another sample of 100 students, and then we get 0.41. So your statistics can vary. However, there's only one true parameter. Maybe again, let's say the true parameter is maybe like 40%. There's only one true parameter. There's only one true actual proportion of teenagers that smoke weed. So we need to make sure you understand the distinction, because that's going to be what we're going to be dealing with in this chapter. And like I said, and like you probably obviously know, we're not going to know the actual value of the parameter, because there'd be no point of then doing statistics. Because if we knew the actual value of of a proportion of teenagers that smoked weed, then we wouldn't need to gather data. The point of gathering samples is to get an idea of what that true parameter value is. Now, if you probably noticed in your calculator when we were doing earlier problems, we use different symbols for the same characteristic. So like when we're talking about sample statistics, we tend to use usually not use the Greek letters, depending on what we're dealing with. But let's say we want to find the sample proportion. The sample proportion would be p hat, whereas the population proportion or the population parameter would be just p. If we're talking about sample mean, a sample mean would be x bar, whereas the population mean or the population parameter would be mu. So we use different symbols to represent population parameters versus sample statistics. Okay, so let's go over practice problems. It's always the best way to really understand this stuff. Okay, so we're going to look at two different settings, and in each setting, we're going to identify the population, the parameter, the sample, and the statistics. So we want to identify 4 things. Now I don't know why the screen turned on all like red. I think it's a green. Yeah, it's that green. There we go. Okay, so in the first scenario, we have a pediatrician that wants to know the 75th percentile for distribution of heights of 10-year-old boys. So she takes a sample of 50 patients and calculates the 75th percentile, and the sample is 56 inches. So go ahead and try this problem first on your own. So pause the video, and then when you think you know the answers, unpause it, and you can check with me. Okay, so for A, the population will be all of the 10-year-old boys, because that's a group of individuals that the pediatrician is studying, and the parameter will be the true 75th percentile of heights of all the 10-year-old boys. So again, the true population 75th percentile. And then the sample are the 50 patients that she gathers information on, and then the statistic will be that 75th percentile of those 50 patients, which she found to be 56 inches. Okay, so now in the second scenario, we have that the Pew Research Center poll asked 1,102 12 to 17-year-olds in the US if they have a cell phone. Of the respondents, 71% said yes. So again, go ahead and try the problem on your own first, pause the video, and then when you think you got an answer, you can go ahead and unpause it and check with me. Okay, so for this one, the population would be all the 12 to 17-year-olds in the United States. And the parameter would then be the proportion P of those all the 12 to 17-year-olds in the US that have cell phones. And again, we want to use P for population proportion. Then the sample would be the 1,102 12 to 17-year-olds that they took data on in the poll. And the sample statistic, or just the statistic, would be P hat, which P hat would be 0.71. Right, so there you go.